Hello everyone, this is Shilpi Saxena. Welcome to my channel Learning Hub. So in this video, we'll discuss about Banker's algorithm. So this is an algorithm which is used to find out whether it is basically used for deadlock detection, to find out whether that deadlock has occurred or not. Okay, so this algorithm is used when there are multiple instances in any schedule. Multiple instances means multiple CPUs, multiple printers, multiple hard disks, or anything. Means instances are more than one in number. To find the deadlock, we will use this Banker's algorithm. It is named so because it is basically used in banks only for the bank to decide whether the loan will be issued or not, if the loan will be sanctioned or not. That is why it is named Banker's algorithm. So without wasting time, we will just start one simple question. In this question, you can see how the question is given. See children, this is very important question which is very frequently asked in GATE exam. So you can see, considering the system has 5 processes. These are the processes P0, P1, P2, P3 and P4. Fine. So resources type A has 10 instances. This is allocation, means already these processes are handling these resources. See number. And this is the maximum number which this process will be needing. These are the maximum, means it will, suppose A is for CPU, B is for printer, C is for HDD. Okay, so P0 will require 7 CPU, 5 printers and 3 hard disk. Similarly, all these are pre-decided that these number of resources will be required, and already available are these resources. Now how we will solve this question? This will be all given. Now to solve this question, I'll move to my sketchbook. So you can see here how we will do this. I'll just zoom it. Now what we have to do is, we have to start with one more column. We will add one more column, that is required. How many will be required? Okay, so required will be already allocated 0, 1, 0, 0, 1, 0, and it requires, it maximum amount it will be required, will be 7, 5 and 3. So what we will do, we will subtract 0, 1, 0 from this. So required will be, this is A, this is B and C. It required will be 7, 4 and 3. Required will be 7, 4 and 3. Similarly, allocated 2, 0, 0 means 1, 2, 2 will be required. 3, 0, 2. 3, 0, 2. So will be required 6, 0, 0. Now 2, 1, 1. 2, 1, 1. So 0, 1, 1. 0, 0, 2. 0, 0, 2. We'll subtract it. 4, 3, 1. So this is the maximum number that it will require. Now we will see the available resources. So we will start from P0, P1, P2, P3 and P4. We'll start from P0. We'll see how many A resources require. How many A resources are required? 7. We have already only 3. So this will not be executed. We'll move to P1. It will require 1. We have available 3. So this can execute. Now 2. It has available 3. Fine. It require 2 and we have available 2. Means P1 will execute first because it can get the number of required resources. Fine. Once this P1 is executed, or whatever P1 already have will be released. Already it had the available were 3, 3, 2. These will be released plus 2, 0, 0 will be released. So available resources will become 5, 3 and 2. Now we'll move to the next process. 6 will be needed. We have already only 5. P2 will not execute. P3 0 1 1. This is less than whatever are available, means P3 will execute. When P3 will execute, P3 have holded 2 1 1. This will be added 2 1 1. Now available resource will be 7, 4 and 3. Now we will check P4. Okay, now P4 require 4 resources. We have 7. It requires 3 resources. We have 4. It require 1 resource. We have 3. So P4 will execute. P4 will execute. Now after the P4 executes, it will release whatever it was holding. 0 0 2 it will release. So what will be available? 7, 4 and 5. Now these 3 are already executed. Again we will check whether P0 will execute or not. P0 requires 7, we have 7. It requires 4, we have 4. It requires 3, we have 5. So P0 will execute now. When P0 will execute, whatever resources it was holding, it will release it. 0 1 0 means available will be 7, 5 and 5. Now which one is remaining? P2 was not executed. P2 was remaining. We will see whether now P2 can execute. Yes, because we have available resources now. P2 will execute. The solution of this question is there is no deadlock in the given situation because there is no because all the resources will be available to all the processes and flow of execution will be P1, P3, P4, P0 and P2. So this can easily execute without deadlock. So this much you have to find it out. So I hope you understood this. One more example I'll explain in my next video. If you like this video, please like and subscribe, hit the bell icon. Thank you and have a nice day ahead.